Hi, so this is the AP study session for particle motion. The first question in this packet is actually pretty hard, so we are going to skip it and come back to it. Look at number 2. The velocity of a particle moving along a line is v of t equals blah 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 measured in meters per second. How many meters did the particle travel from 0 to 4? Well, remember, distance traveled is the integral of velocity. So I'm going to integrate from 0 to 4. 3t to the 1/2 plus 5t to the 3/2 dt. Set up your antiderivative. Okay, and then think about that if I take 1/2 and I add 2/2 to it, because that's the same as 1, right? 1/2 plus 2/2 is t to the 3/2. But then I have to divide by 3/2, that's the same as a 2/3, but then there was already a 3 in the front. So this 3 and that 3 are going to cross out with each other. Okay, then plus. Okay, I'm going to add 2/2 to my 3/2, because remember, that's how you take an antiderivative. So I'm going to add 2 over 2 to 3 over 2. I'm going to get 5 over 2. But then if I have to divide by 5 over 2, that's really multiplying by 2/5. There was already a 5, so bam, my 5s are gone as well. So this is really 2t to the 3/2 plus 2t to the 5/2. Then I'm going to plug in capital F of 4, then capital F of 0. Now, 0 is going to be easy. It's going to just be 0. So plugging in 4, it's 2, 4. 3 is the power, so cubed. 2 is the index of the root, so it's a square root. Plus 2, 4. 5 is the power, 2 is the root. And then remember, you always want to do the root first just because it's easier. You technically can do them in either order, but the square root of 4 is 2. 2 cubed is 8, and 8 times 2 is 16 plus. Then here, square root of 4 is 2. 2 cubed is 32. Multiplied by 2 is 64. And then 16 and 64 would add up to be 80 on the top. Then from there, top minus bottom, 80 minus 0 is 80. Okay. Part number 3. For time greater than 0, the velocity of a particle moving along the x-axis is given by, boom. What time is the acceleration equal to 0? Well, remember that acceleration is the derivative of velocity. And so the first thing you should notice by looking at that is that this is going to require product rule. So I'm going to set up my product rule. My u is going to be t minus 5. My v is going to be t minus 2 squared. So my u prime, the derivative of t minus 5, is just a 1. V prime, the derivative is going to be 2 to the front. T minus 2 to the first power, which I'm not going to put because I don't want it to look like a prime. But then after that, I multiply by the derivative of the middle, but the derivative of t minus 2 is just a 1. From there, I'm going to set up my cross diagonal. So it's going to be 1 times t minus 2 squared plus t minus 5 times 2 times t minus 2. Now, the 1 here, I'm going to kind of let that go. You can put it if you want to. You don't have to. Now, remember, I want to know the values where the acceleration is equal to 0. So I am now going to set this equal to 0. And what you should notice is that both of your terms have something in common. They both have a t minus 2. So I'm going to factor that out to the front here. And then I'm going to put whatever's left over in a second set of parentheses. I'm going to use a bracket, but it's the same thing. Okay, so here I'm leaving behind a 1 and a t minus 2. And then here I'm leaving behind a 2 and a t minus 5. Okay, well, let me go ahead and distribute here. This is really a 1t minus 2 plus. This is a 2t minus 10. Well, then I can combine like terms in there. Really, I have a 3t minus 12. Now, keep in mind, you still have a t minus 2 even in front of that. So from here, I'm going to factor out a 3 from this. So I have 0 equals t minus 2, 3's coming out, t minus 4 is left over, which means that 2 and 4 are going to be my two places where acceleration is 0. Okay. All right, go ahead and turn the page for me. All right, number 4 is going to be very similar to the one that we just did. It says a particle moves with position, blah, 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 where A and B are constants, A and B aren't the same. For which of the following values of t is the particle at rest? Okay, at rest means that your velocity function needs to be equal to 0. So if this is position, then for me to get velocity, I need to take the derivative. So v of t equals x prime of t. And then I need to take the derivative of this. Now, you have two choices. Some people will go ahead and multiply that out. And so that's how I'm going to choose to do this. But you could also do product rule, which is normally how I would teach that. However, somebody was like, can't I just times it out? And I was like, well, yeah, I guess you could. So first, let's come over here to the side and rewrite our x of t. So we have t times t is t squared. T times minus b is minus bt. A times t is minus at. And then negative a times negative b is plus ab. Now, keep in mind that a and b are both constants. So when I take the derivative here, the derivative of t squared is going to be 2t. The derivative of minus bt is going to just be minus b, because remember, this is a constant, so I times, that's like a t to the 1. So I times my 1 down, I get a negative b, right? Then on my second one, I get a minus a. But then if this is a constant, then think about, no matter what a and b are, when I take their derivative, I'm going to get 0. So from here it says, for which of the following values is the particle at rest? Well, then if this is my velocity, I'm going to set that equal to 0. And then remember, I'm trying to solve for t here. So I'm going to take my minus a and my minus b, I'm going to add those across. So now it's a and b both positive equal to t. Then divide by 2. So it's a plus b over 2. Good? All right, let's go back to number 1. So that would actually be answer choice B here, right? Okay, so let's go back to number 1. So I put number 1 at the front of the packet because it didn't really look that hard. But then once I actually read through it, it actually has quite a bit going on. So the first thing that I want to look at is that it says particle travels in a straight line with a constant acceleration of 3. Acceleration is 3. That's what they give us right there. Then it says meters per second per second. Meters per second is the same as meters per second squared. Okay, so don't overthink that part of it. Then it says here, if the velocity of the particle is 10 at time 2, so that means that the velocity at 2 is 10. Then it says, how far does the particle travel during the time interval when its velocity increases from 4 seconds to 10 seconds? Okay, so let's kind of ignore that for right now. We have this, we have this. Let's find our velocity equation. So we know that v of t is the integral of acceleration. So if I wanted to integrate 3, that's going to be 3x, or 3t plus c. Then remember, in order for me to know what my plus c is, I need to know an ordered pair. Well, they gave you one right here. So if v of t is 3t plus c, and I know that 10 is the answer when I plug in 2, well then 10 equals 6 plus c, well then c has to be 4. So now I know that my velocity, v of t, is 3t plus 4. Okay? Then it says, how far does the particle travel? Okay, well, I at least know that if I want to know how far the particle travels, I'm going to have to set up an integral. So my travel distance is going to be the integral of 3t plus 4. But then the problem is that they don't even give me time values. Okay, instead, they give you some more complicated crap for you to try to find those two values. So let's see when. It says during the time interval when the velocity goes from 4 to 10. Now, if I want to know when the velocity is 4, I need to set my v of t equal to 4 to find when that happens. So think about this is, oops, I wrote the wrong number there. That should have been a 4. Okay, from v of t equals 4 to v of t equals 10. That's my interval. So instead of them giving you times, they're giving you velocities and making you go backwards. Now, the math behind this is not hard. If I want to know when the velocity is 4, well then set the equation equal to 4. 3t plus 4 equals 4 when t is 0, because I'd minus my 4 across. 3t is 0. Well then t equals 0. So that's my bottom value. Then the other time is when the velocity changes to 10. Now, you could set this equal to 10. 3t plus 4 equals 10. However, this is actually the point they gave you. Do you remember when the velocity was 10? Velocity is 10 when at 2. So that means that 2 is your other endpoint. And so now that I know my endpoints, I can set up my antiderivative. So it'll be t squared, 3 over 2, and then antiderivative of 4 is 4t. Then we're plugging in 2 and 0. I'm going to do 0 first. These both 0 out. 2 squared here is 4. So I have 3 halves of 4 plus 4 times 2 is 8. And then a little bit of math here. I'm going to do 4 times 3 is 12. Divide by 2 is 6. So really that's 6 plus 8, which comes out to be 14. And then if it's 14 minus 0, that comes out to be 14. Okay. So again, it's not like the math in that one was super difficult. It just feels kind of like you're on a rabbit trail while you're solving it because you're missing so much stuff. Okay, so next one that we're going to look at is going to be number 7. Okay, so first thing that you're going to need for this question is a calculator, so hopefully you already have one out. If not, pause the video and go grab one. It says a particle moves along the x-axis so that its velocity, 0 to 5, is given by, then you have an equation. So first thing I'm going to do is go ahead and type that in. So I want the ln of x squared minus 3x and then plus 3. Okay, then I only care about it from 0 to 5, so I'm going to go into my window, 0 to 5. Then I'm going to look at my second table, and I'm going to kind of look at the values. It looks like it kind of stays pretty close, so look, 1, 0, 0, 1, 1, 2, 3. So it looks like if I want to adjust my window, I can make this like -2 to maybe like 5 or something. Okay, and again, these are just estimates to kind of give me a good looking graph to where I can see stuff. Okay, so I'm going to sketch it right here. So it goes down, up. Okay, and then at this point, remember, I'm cutting my graph off at 5. Okay, let's look at our question. Part A, is the particle initially traveling towards or away from the origin at 0? Okay, well, let's think about what we know. First thing that we know is that this is my velocity graph, right? This is v of t. So at 0, I can see that it's positive. Now, if I want to know exactly how positive, I can go into my chart. At 0, the y value is 1.0986. So I'm going to start with this. V of 0 is 1.0986. Now, because that is positive, I know that my particle is traveling to the right. There is another piece that is missing, though, for me to know if it's traveling towards or away, and it's my position. So I also need to know x of 0. And if I have velocity, that doesn't really help me find my position at 0. But if I go back to my question, the particle is at x equals 8 at time 0. So that means that x of 0 is 8, which is also positive, which means that my particle is on the right side already. And so think about, here's my number line, here's 0. Okay, my particle's on the right and it's traveling to the right, therefore it is traveling away. Okay? Part B, find the acceleration of the particle at 4. Now, whenever I give this question, there's always somebody who's super extra that tries to take the derivative by hand. Waste of time. So if I want the acceleration, a of 4 equals v prime of 4. And then you do it in your calculator. Do not do it by hand. It's a waste of time. So I'm going to go back into my graph. I'm going to hit second trace. I'm going to go down to the dy dx option, which is number 6. Okay, and then I'm going to take the derivative at 4. So it tells me that my slope at that point is 0.7142. 0.7142. Then it says, is the speed of the particle increasing or decreasing at time? It should also say a 4 right there. So if you will fix that, please. It should be the same time value we just did. Okay, so let's think about for a second. We know that our acceleration at 4 is 0.712. In order for me to know stuff about speed, I also need to know the velocity at 4. Now, when I look at my chart here, okay, I can see that my 4 over here is positive. You do still need to find it. So I'm going to go into my table. At 4, I see that my velocity is 1.9459. That is from the table in my calculator. This is the slope in the graph. Okay, because remember, my y1 is actually typed into my calculator. Okay? So from there, think about it and decide if it should be towards or if it's speeding up or slowing down. Okay, you should put it right here. I'm videoing, so but you can still leave it there. Okay, so hopefully you remember that if you're considering speed increasing or decreasing, you're looking for whether or not these numbers have the same sign or opposite signs. So that one came out to be positive. That one came out to be positive. That means that your graph speed is increasing. So, therefore, speed is increasing because A of 4 and V of 4. Okay, bye, I'll see you 7th. Have the same sign. Okay? Alright, part B. Oh wow, 2 part B's. Bonus. It says, find the times on the interval from 0 to 5 where the particle changes direction. During which times does the particle travel to the left? So remember, your particle is going to change direction when v of t changes sign. Okay, because it's velocity sign that tells you which way it's going. So that means specifically I'm finding these 2 points right here. So, second trace, gonna find the 0. Then this one, it looks like it happens right around 1. So remember that you can just guess numbers around 1, or you can move your little cursor, which is what I'm gonna do. So I'm gonna go on the left side here, then kind of get below it on the other side. Okay, this one is at 1. Second trace, 0. Now I'm going to go to the other one. The other one happens at 2. So, nice, easy whole numbers. So then it says, when does the particle change direction? We would say at 1 and at 2, because v of t changes sign. And then it says, during which intervals does the particle travel to the left? Well, then it's going to travel to the left on this part here, because remember, left counts as a negative, and that's where my graph is below the x-axis. So, So from 1 to 2, my particle travels to the left because that's where v of t is less than 0. Okay, part C. Set up an integral expression for the position of the particle at time 2. Okay, so I want you to think about it. If I want the position at time 2, they have to have given me the position. So think about, this is what I want, is x of 2. Well, then they had to have given me the position at a different time. So if I go back up and look, remember in part A, we found out that x of 0 is 8. That's what we have. So if I want x of 2 and I have x of 0, then x of 0 is going to have to be added to the integral from 0 to 2 of my velocity. Now, keep in mind that whatever is in here in the integral should be the derivative of what's on the outside. So if these are positions out here, then that should be velocity in the middle. Okay? Then remember that x of 0 we said is 8 plus, and then this part I'm going to type into my calculator. Now notice that since I already have my graph pulled up, I'm going to do it here, but it's second trace, pick the integral option, which is number 7, and then I'm going from 0 till 2. So 0 to 2 is 0.3686. So it's 8.3686. Okay? Next one says, set up an integral expression for the position of the particle over the interval from 0 to 2. I guess that's kind of the same thing, but you would just say x of t equals whatever x of 0 is plus the integral from 0 to t of v of t. So basically you're just saying it could be any time value. You just put whatever that value is here. So you're going to have to start at 0, but then you're going to integrate until whatever value you want to stop. Which doesn't really, I don't know that they'd ask that on the AP test, but it's a good thing to think about that you can always make this generic by taking the 2 out and just putting like an ambiguous variable in its place. Okay? All right. Let's see. I think we have time probably for one more. So let's look at this last one here. Okay, it says, in which direction, up or down, is the particle traveling at t equals root 3 pi halves? Now, this one I think is possibly a no calculator question. So if I want to know if it's going up or down, I need to check the sign of velocity. So let's see what v of root 3 pi halves is if I plug into here. So it's going to be 3 pi halves times the sine of 3 pi halves square rooted, but then also squared. So I want you to think about that. If I'm going to square and square root it, these guys are really just going to cross out, and I'm just going to have the sine of 3 pi halves. So I have root 3 pi over 2 times the sine of 3 pi halves. Now, if you do your hand trick, okay, pretend here's your hand, pi halves is your thumb, fold it down. Okay, you can see that all of your fingers, look, here's your happy little alien hand. Okay, here's pi halves. You have all 4 of your fingers on the bottom, so that means that it's going to be 1. But then we have to think about what quadrant we're in. So if I'm at 3 pi halves here, in my all students take calculus, or however you remember it, remember that here at pi halves, we're positive. But if I go down to 3 pi halves, look at the signs of sine on either side of that line. So here, tangent is positive, but sine is negative. Here, cosine is positive, but sine is negative. So if it's negative here and it's negative here, then it's going to still be negative on that axis in the middle. So really, that's a negative 1. And if I multiply a negative 1 by this kind of random number, that's going to come out to be less than 0 overall. Then v of root 3 pi over 2 less than 0 means particle is traveling down. Part B says, find the acceleration of the particle at any time. Now, this is bad news for us, because if you had a calculator, you could just take the derivative at any point, but if they want it at any time t, that means you have to do it by hand. So, v of t equals t sine t squared, and I want acceleration, which is v prime of t. That's the derivative. I am going to have to do product rule. So let's set this up over here. My u is a t, my v is a sine t squared. Then u prime, the derivative of t, is just a 1. But then v prime is actually going to require chain rule. So think about, I'm going to take the derivative of sine, which is cosine t squared. But then I have to multiply by the derivative of t squared, which is 2t. So when I set up my derivative here, I'm going to do this diagonal first. So it'll be 1 times sine t squared. And then on my other one, it's going to be t times cosine t squared times 2t. Now, you could always combine this t and the 2t and make it a 2t squared if you wanted to, but I'm not going to just because I don't feel like it. Okay, so it says, find the acceleration at any time, check. Okay, part C. Set up an expression involving an integral that represents the position of the particle at time 2, given that the position of the particle is 6 at time 1. Okay, so this is what I want. This is what I have. So let's unscramble. The position is 6 at 1. Well, then the position of 1 is 6. So this is another version B. You do x of 2 equals x of 1 plus the integral from 1 to 2. And then remember, whatever goes in your integral should be the derivative of what's on the outside. So if these are positions, this should be velocity. And then from here, if you did have a calculator, you would do 6 plus the integral 1 to 2 of t sine t squared dt, which you would need a calculator to do by hand anyway. So that's why it just says to set it up. Okay, part D, set up an integral expression for the distance traveled by the particle over 0 to 4. Now, what you should realize from part A is that there are sections of this graph where the value came out to be negative. But remember that distance has to be positive. So remember that the way that we find distance traveled is you're still going to integrate from 0 to 4, but you have to take your v of t and you have to put it into absolute value bars. Okay, and then from there you could easily do that in the calculator as well, but notice that it says set it up because this was a no calculator question. Okay, last part, part E. Set up an integral expression for the average velocity of the particle. Okay, so think about, in my question, they gave me velocity. I want average velocity. They gave me velocity. I want average velocity. Well, then this is average value. If they had wanted average rate of change, remember rate of change is a derivative, they would have had to ask you for average acceleration, okay, which is not what they asked for here. So average velocity would have been 1 over 4 minus 0, integral 0 to 4, and then your function v of t right here. Okay. Now, let me write down what I just said a minute ago. If they had asked you for average acceleration, that would have been the average rate of change. Because remember that a rate of change is a derivative. A rate of change is a slope. So acceleration is the slope of velocity. So you would have done v of 4 minus v of 0 over 4 minus 0. And so you really have to think about the two differences there. Average value is 1 over b minus a integral a to b, because you want average velocity. This is velocity, that's velocity. Okay, but average acceleration would be the average slope, which is your y2 minus y1 over x2 minus x1. Okay, so then remember, you can do your little practice here, and good job. And actually, let me just do one more. We skipped the one in the packet that was like this, but remember that if you're looking at a velocity graph, okay, and you want to know when the particle is traveling to the right, you would be looking for where your velocity is greater than 0. So if I look at my graph, I can see that happens when it's above. So that would be just from 3 to 5. Then it says, when is the velocity increasing? Well, remember that velocity increases when its slope is positive, right? That's what increasing means. So I want v prime to be positive. Well, then if this is a graph of v, then that means that v prime needs to have a positive slope. So looking at my graph, I can see my slope is positive from about here until here. So looking at my answers, it looks like 1 to 4 is going to be the correct answer choice there. Okay, then for my last part, question 5, it says, when is the speed increasing? Remember that speed is increasing when v of t and a of t have the same sign. When v of t and a of t have the same sign. And so then remember that if this is v of t, then this is above or below. These are the y values. And then a of t is the derivative of v, so this is the slope. So that means that I can either be above with a positive slope, or I can be below with a negative slope. Okay, and those would be my two combinations that would make my speed be increasing. So, above with a positive slope would be from 3 to 4 only, and then below with a negative slope actually happens twice. It'd be here and then also here. So I have 3 sections where that happens. And it looks like that answer's not here. So it should be, we'll add in an extra little section on part D. Should be 0 to 1, 3 to 4, and 5 to 6. Okay? Ooh, that was a short little session. Okay, good job.